Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
This podcast episode for Cut the Crop is from the 2023 FAR Conference, where David Aglen joined from Scotland, where he is at the AHDB Strategic Cereal Farm. David talked about increasing plant and soil health and reducing inputs.
I'm indeed the farms manager at Balbirnie Home Farms here in Fife in central Scotland. We are a mixed farming business trying to farm in a regenerative fashion. And we've been trying to do this for the last 7 or 8 years with a steep learning curve as we've been going along. The numbers are a little bit different to what Trish says, but the basics are pretty well similar. We're part of a 2,000 hectare privately owned family estate, and I manage 1,150 hectares in hand. 650 hectares currently is combinable cropping. That number's come down from 800 previously as we spent more time investing in integrating our livestock back into the arable part of the business. So we've actually got more forage crops and more livestock feed grown as well as grass than we used to. The vegetable and potato area has reduced significantly over the last 10 years. We found they're quite damaging to the soil and we're hindering our regenerative journey quite dramatically. We also have about 90 hectares of summer cover crops and kale for outwintering all of our cattle, including young stock. 320 hectares of grass. The livestock numbers vary. We've now got 1,000 breeding ewes on the farm to get a bit more diversity into the livestock, and they provide a very useful role throughout the winter with our cover crops, which I'll touch on later. As well as the farming, with 400 hectares of forestry, mostly conifers, but a proportion of deciduous hardwoods as well. And in 2020, we were approached to be the strategic farm for Scotland for cereals. This is a 6-year project. It's a bit like, I believe you have a Pathfinder farm project in New Zealand. And this is similar in that it's levy funded by the AHDB, and 6 years we felt was long enough for us to look at a good proportion of the rotation and actually get some meaningful data out of it. Any project for 1 or 2 years, there's so much weather information can change it season to season and we get different results. Whereas over 6 years, we felt we'd get something that we could give back to our peers as a meaningful data set. We agreed to go into the project on the basis that we wanted to do it based on regenerative farming, very much around what we were trying to do here at Balbirnie, and weren't particularly interested in discussions about whether it was better to plough or not to plough a field. We weren't going to plough, so if they wanted the project to happen, it was going to happen without it. A bit of information about the details among the business. Shows where we are, about 30 miles from Edinburgh, north of Edinburgh, in central Fife. Our altitude, we range from about 50 metres above sea level at the eastern end of the estate, which is the bottom right-hand corner, up to 380 metres above sea level on the northwestern edge of the estate, the grey bit at the top left-hand corner of the map, where we've got a heather hill up there. So quite a diverse landscape, lots of trees, small fields, large fields, quite steep gradient on a lot of the ground. We're predominantly a sandy loam soil with some clay content in the subsoils, which can be helpful in a drier time. We do have a lot of deeper sands as well, which just burn up, and that's the way we just have to live with that. The majority of the arable operation is to the east, and it's about 100 metres above sea level. Our rainfall typically is about 1,200 millimetres to the west end of the estate and about 900 millimetres to the east end of the estate. We are about 1,400 kilometres further away from the equator as to where you guys are all sitting just now. And that brings with it a fair number of challenges through the seasons, and particularly towards the tail end of the season, at the end of harvest. Although I'm sure there's a few people in the audience here that have got family or indeed are from this part of the world initially. Anyway. So we, as part of the strategic farm, we set about, we wanted to look at things that would be relative to ourselves here at Balbirnie, but also to the wider industry going forwards. So we have a committee of about 12 people, some farmers, some stakeholders from environmental groups and government organisations. The idea was we'd try and, looking forwards, see if we get some input into forming part of the new agricultural policy that's going to happen in the next few years. So we thought, well, if we get these people in beside us, then we can show them what can be done, potentially, and the pitfalls as well of some of their ideas, perhaps, and we can all go forwards more positively rather than fighting against each other. So with that in mind, one of the things that was strong in my upper part of my mind is that we seem to be losing the battle with fungicides and herbicides, more so fungicides in this part of the world, against diseases, and particularly in the wheat crop, the winter wheat crop. The result of that is basically we can't really control septoria in this part of the world now. Varietal resistance is pretty much all we've got left. I spent yesterday, or 2 days ago now, walking around a very extensive set of trial plots that had every fungicide known to man thrown at them in every possible combination, and the crops were still dirty. So we're running out of options. For a few years, we'd been tinkering on the farm, having learned the idea that if we keep the crops healthy, then perhaps we don't need the fungicides, or we can do with less of them. So we thought, well, let's put this into the trials and see if we can tease some more information out of it, a bit more funding behind this, a bit more rigor and discipline behind the work. We might be able to find some answers for everybody. So the idea was to manage the winter wheat crop nutrition in order to reduce the requirement for fungicides, or ultimately eliminate them. Next on the list, also been learning about the use of foliar urea as a nitrogen source as opposed to putting it on the soil. And I was quite intrigued with this because some of the claims were quite staggering, that you could get anything from 3 to 8 times the amount of output per kilo of nitrogen versus using ammonium nitrate or urea straight onto the soil. So an opportunity potentially to massively increase the nutrient use efficiency there. And this was all done before nitrogen and fertilizer prices had gone through the roof last year. So of course, when last year came along, it became very relevant. So we're trying that. Thirdly, the spring barley crop for malting, as many of you will be aware, is a very strong and important crop up in this part of the world. So we thought we had to do something with that. We've been working away direct drilling on the farm for nearly 10 years, on and off. And the one crop we struggled with the most has been the spring barley. So we thought, well, let's try and tackle this. We're also growing a lot of winter cover crops, overwintered cover crops on the farm. Basically, every acre that's going into a spring crop will have a cover crop on it throughout the winter. This helps with our livestock integration because it enables us to get stock onto arable fields and cycle some of the nutrients back round, and some of the fertility that we're capturing from the end of the summer and the growing season, we can bring back round into the following season if we're clever enough and lucky enough. So that was important. And then also try to find a blueprint for successful establishment of spring barley. Over the years of trying to direct drill spring barley, we find it a very, very fickle crop to do this successfully, with mixed results, everything from big crops to small crops and everything in between. And doesn't seem to be much rhyme or reason as to why we were getting good results versus bad results. So we thought, well, let's see if we can tease this apart. Government policy is going in that direction. It's going to become an important thing, and if we can come up with a blueprint for our peers, then maybe that'd be a useful spend of the money, as it were. So we'll go into a little bit more detail. I haven't got a huge number of facts and figures for you guys, I'm afraid. I'm sorry, it's very basic farmer-style trials in terms of what I've got to say today. There's been much more information available on the AHDB website, and as we go on in the project for the next 3 years, then we'll obviously be able to build on that data set. So these are all the trials, I must say, they're all full-scale tramline trials, so they're not plot trials at all. We're running 36-meter tram lines, so these are big scale with full commercial kit, and we have to fit everything in between all our other jobs. So if 2 tram lines or 1 tram line needs one particular treatment different, then we have to fit it in, and more importantly, we have to remember to fit it in, which sometimes is a bit challenging. Also, if there's any loss as a result of income, the crop on a particular trial doesn't yield as well or whatnot, we have to take that on the chin as a business. We don't get compensated for any crop loss. So with that in mind, we try and limit that. So on the wheat front, managing the wheat with the crop nutrition, we've got 4 different plots in there. There are 2 replicates of each, and basically we have an untreated plot or tram line, which just gets standard fertilizer, which for us at the minute is 160 kilograms of nitrogen a hectare, plus a plant growth regulator. Then there's a treated plot, which is the same as the untreated, but gets a full standard fungicide package. So that would be, for here, that would be a T0, T1, T2, and T3, and writing a lot of checks at the end of it too. Then we've modified nutrition, which is basically we are tailoring the nutrition requirement to the crop to try and keep it healthy. And then on top of that, this year, we added the idea of using some biology, the notion that we can use some bugs in a jug or out of a bag to try and coax the crop into a bit more health and productivity. So we've taken tissue samples throughout the season regularly, starting in early March, and the last ones are taken just before ear emergence. And they're sent away for sap analysis, and the idea is that we respond to the requirements of the crop. Now, to keep its nutrient status in balance. Now, this has proved a lot harder to do in practice than the theory would suggest. Problems arise with getting things to the lab on time, then the lab responding quickly enough, then them giving the results in a format that you can translate and work with. And then lastly, but not least, it's getting the product on farm to try and correct the issue. So the first couple of years were a bit tricky with this. We've got a lot better at it this year, a lot slicker, and we seem to be able to react better. As a consequence of this, the results in 2022 were a bit mixed. Essentially, a full fungicide program out-yielded anything else we did. No surprise there. But this year, we seem to be seeing the reverse. The crops that we've managed, the nutrition in, and are looking notably cleaner than anything that we've put a full fungicide program on. I did say earlier on how we take the hit for any loss on these crops. One of the biggest problems we have is yellow rust. we seem to get a handle with the nutrition and biology on the wet weather diseases, so mildew and septoria. We seem to have kind of be able to keep them in check. But the yellow rust has been really, really difficult to handle. So what we've done, it sounds a bit odd from a trials point of view, and I apologise, but we actually have sprayed all of the plots for yellow rust twice this year. I wasn't prepared to put up with a 5 tonne a hectare loss on about 6 or 7 hectares for the sake of a cheap fungicide. And that was discussed with the trial operators and the AHDB, and they're quite happy for that. To be well noted that we lost the battle with the yellow rust, so we just had to swallow our pride, and we'll try and learn more over the winter and see if we can get some more data on what is potentially missing from our crops or our soils to help the yellow rust. Crop resistance, variety resistance gets you so far, but they don't seem to last long. It seems to be a couple of years and then varieties break down. I would imagine you guys are having this similar issue over there. Next was the use of the foliar urea. This trial is much more simple to manage and deal with. So industry standard generally is use of ammonium nitrate. So we'd put 2 applications of ammonium nitrate granules, totaling 160 kilos of nitrogen on a couple of tramlines. The next plots would be first dose of ammonium nitrate and then followed by dissolved urea put onto the soil. And then lastly, it's the dissolved urea on the soil for the first 80 kilos and then topped up with 6 foliar urea applications to try and get to the 160 kilos. Urea, the initial problems we thought about this trial would be the extra passes with the sprayer, but we soon discovered we can chuck urea in with fungicides and lots of other things, so it hasn't really added any extra time going through the crop. Last year, the ammonium nitrate, the plots that got solely ammonium nitrate came out on top. We're obviously not at harvest yet, but just looking at them this year, it's in reverse. The foliar plots look by far and away the strongest, and the ammonium nitrate ones look the weakest, which has surprised everybody. But we had a very wet March, so perhaps the ammonium nitrate got a bit more leached out the soil than we might expect. So that might add to that. We're also looking at, for next year, we're trying to keep the same series of trials throughout the whole project, but we might tweak them as we go along. So as we're learning more, we're learning that we can get further up the protein building chain within the plant by using amino acids. I've tried a little on the farm ourselves this year, and I'm quite happy with the result. So I think we might add another replicate into this trial next year and start looking at amino acids to see if we can get even further, even reduce our nitrogen usage even further, potentially. Onto the spring barley. Can we successfully grow cover crops over the winter, followed by direct drilling of spring barley? So this trial and the fourth lot of trials, which is looking at the drilling dates of spring barley, are overlaid on top of each other, so they all happened in the same field, in the same plot, which is quite confusing and ties us in knots some days. So essentially, we had 2 different cover crop destruction dates. So we'd sow a cover crop in the autumn, which last year was an Australia harvest, so they all went in August. And we used beans and oats and peas as our main cover crops. We've tried using all the small fancy seeds. They look nice, but they don't do a great deal for us, whereas actually these biggest, largest seeds, they get going, they've got enough vigor, and they produce a good amount of biomass above and below the ground. For us, the above biomass is important from a livestock grazing point of view. So 2 different destruction dates and 3 different sowing dates. So we have plots with no cover crop, plots with cover crops destroyed pre-sowing, and plots with cover crop destroyed after we've drilled the spring barley. The best initial results last year were where there was no cover crop at all for the winter. So basically just stubble with a few weeds growing on it. And the worst was when the cover crop was destroyed post-drilling. However, we have been looking at biodiversity and environmental factors across the farm as part of the project as well. And it was spotted that there was a greater abundance of biodiversity in the plots that were left to grow. The cover crops were left to grow longer, so therefore the ones that were destroyed after the spring barley crop was drilled. So there are more spiders and beetles, etc., beneficial insects. So if our government want to pay us to keep these things, then that information is of use. However, I would suggest that 1.5 tonne a hectare yield reduction as a result means that the money to compensate has got to be quite big. And I would imagine not many people will go for that. And I don't think they'll pay that much either. What we have done on farm, our own farm practice with the introduction of the sheep, is we grazed all of our cover crops over the winter with sheep. We managed to tease out over the last couple of years that slugs were the big issue in the spring. They don't need a great deal of straw or stubble to hide behind here. And they were just hampering the establishment of barley, ending up with thin crops and patchy establishment. We've put the sheep in over all the cover crops over the winter this year. Basically, their feet just pad it all down and firm it all up without creating any compaction as long as we move them on quick enough. They're only on each area for 2 or 3 days at a time, and even less if it's very wet. And the result is our own spring barley, commercial crops across the farm, look as good as any crop established by conventional means, so that'd be ploughing and power harrowing. So we're going to put sheep grazing into this trial for next year. Just to keep you all awake, here's a photograph of our spring barley plots. So you can see the layout. You've got 3 plots with no cover, and then you've got all the cover growing that's going to be destroyed at various parts in these tram lines. This picture was taken in the middle of November last year. It was a great year for growing cover crops, so whether we can repeat it or not another year, we'll see. Lastly, onto the spring barley drilling dates. It's always been suggested that we should wait till later in the spring to sow our spring barley for direct drilling. I don't know how you guys find it. So we wait patiently, have done for a few years, for all our neighbours gallop along and sow their barley crops. We sit there twiddling our thumbs. So we thought, well, let's just see if we can tease this apart. I'd heard some anecdotal evidence from England, guys down south I know, who were suggesting that they'd started to drill their spring barleys earlier with no-till, and they were getting better results, more consistent results. So we thought, right, well, let's try it. So we wanted 3 different sowing dates. We start off basically when the neighbours start sowing their crops, assuming our ground is fit enough to travel. And then we'd have 10 to 14 day intervals, obviously dictated by the weather conditions when we do the next 2 sowing dates. The results, last year was the first year of this trial. The results were not as we expected. We thought the middle to the later sowing would do better because the theory is the ground's warming up, so the crops get going better. Not a bit of it. The early sown crops yielded far more. Again, we changed farm practice. We just started sowing as soon as we could this year, and what a difference it's made. So yeah, it's amazing. We're learning quite a lot as we go on the farm, and hopefully we can continue this for the next few years and bring up some useful information. So what's next? What we see in the farm is that we use all of these methods and all the stuff that's in the trial we do on farm anyway now. And we find it's generally a combination of them all, which makes the business a success and is improving our output, both physically and financially. Not to forget about soil health. Our soil structure is improving massively as a result of our regenerative journey. What I'm concerned slightly about with the regenerative farming and science is that it's very hard for trials and statistics work to cope with multiple variables. You'll see in our trials that we're just altering one thing, a sowing date, a cover crop, or the lack thereof, and statisticians and trials can cope with that. But in regen, we seem to need to vary everything to get the result. And I'm not quite sure how we're going to tease all that out scientifically as time goes on. Anyway, with 3 years left of the project to go, as I say, we're getting good results so far, so hopefully we can find a good data set for our peers when we're finished. And we're getting better and better doing trials too along the way. So, thank you very much for listening.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.